Hello everyone, this is Max from Exalted Code, and today I'll be going over some game architecture concepts using Unity scriptable objects. The starting point of this tutorial is actually a little how-to that Unity put out on ways to architect your game using scriptable objects. In this how-to, they give you some examples on how to make variables actually be scriptable objects that you can save to your project architecture, and also how to do the same for game events and GameEventListener. This allows you to have objects refer to events so that they can raise events and have other objects listen to them. This helps you have more maintainable code, have more modular code as well. The system they offer, however, has some caveats, and when using it extensively in a personal project, I found that some improvements needed to be made to the suggested method, and this is what we are going to go over in this tutorial. The starting point of this tutorial will actually be the code that was suggested by Unity, and right now I set it up so that we have a little character over here which can take damage whenever this damage button is pressed. And here you can see an HP bar gets updated, he flashes red, and you hear a little oof sound. Now, if we go over the way this was implemented, here we can see the player has references to scriptable integers, which is his current HP, his max HP, also his last damage taken, and he can raise events such as HP changed and player died. On the side of the HP bar, we simply have a GameEventListener that listens to the current HP changed, and whenever it happens, it updates the bar with the new HP. And if we go back to the player, we have the renderer color interpolator, which takes care of making the player flash red, and the sound player, which plays the sound, which are all listening here to damage taken. And we have a on player died that is listening to the player died event. The first pain point I want to address actually relates to code duplication and encapsulation. If we look at the code provided on the how-to, we can see that here we have two public fields, and also serializedInt is inheriting directly from scriptable object. This is for the serializedInt. If we compare, for fun, to the serialized damage over here, going to put them side by side. And this should illustrate what I mean by code duplication. Except for these two fields, the only difference over here is the type. In this case, a template would be better suited for our needs. In order to solve this issue, we're going to need to create a template class from which we'll be able to inherit. So, we'll be able to move in the initial value, the runtime value, as well as the on, after, and before serialize. Now that I think about it, I had a little oversight right over here. I only defined a getter for runtime value, so let me fix that. Now that this is done, we should be able to go back to our Unity game. It compiles, and if we run it, the behavior should be the same. Indeed, as we can see, the behavior is still what we expected. The second pain point I would like to address is related to the event of value changed. Here we can see that our player needs to have a reference to the current HP changed in addition to having a reference to the current HP. This is a bit redundant in my mind, and it seems like one of the major use cases for these scriptable object variables is to actually have them notify whenever they changed. So I would like to have the game event actually inside the scriptable object that is the variable. So I'm just going to go modify that right over here and add an extra field. Now we'll want to raise this event whenever we change the runtime value. Now, with this in place, we'll be able to take care of removing what we need here in our player. So we don't need to talk about HP changed anymore over here. We don't need to raise it anymore. And we'll be able to simply assign the variable, the event, to our scriptable object, current HP changed, and as far as damage taken goes, last player damage, we'll be able to set here to event damage taken. This means that we can also go over here, and in our damage source, we also do not need to raise this event anymore. And now we'll be able to run the game, and let's see what happens. Well, we do take damage, but only once. Now, why might that be? If we look at the way we deal damage at the moment, we assign the value to our player damage ref, which is a struct which is damage with a fixed amount and a fixed game source. If we look at our serialized damage, our serialized reference, we can see here that the runtime value will not be null, but the runtime value will be equal to value. This means that we'll need some sort of override. In this case, we will add a boolean to the serialized reference to allow always raising the event. This will allow us to have a form of event bus system where we can always apply a value to it, and all the relevant items will react upon a new value being added on it. So let's do that. Now that we have our new field, we'll be able to check it over here and try it out. Everything is back to working as expected. So we have greatly reduced the code duplication, and as a bonus effect, right now, if we want to create a new serialized class, let's say we want to create a serialized float. Well, all we need to do is take our code here from serialized int and change everything for float. So float, 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 and float, and voila, we now have the capacity over here in our create observer menu to create a serialized float. So you can see that this makes it way faster to create new sorts of scriptable variables by using the template. Now the last thing we want to take a look at is how to add the support to be able to set events at runtime to our GameEventListener. So in order to do that, it's rather simple. We just go to our GameEventListener and we will add a setter function. As you can see here, when we set the event, it's important first that if we had a previous event to unregister the listener from this. Afterwards, we'll be able to simply assign the new game event and register immediately. Now this does have a slight side effect, which is that sometimes you can have a listener that was destroyed, but that is still registered to an event. In order to deal with that, the only thing we need to do, since we're already traversing in a reverse order right over here with the raise in game events, we can add a null check, and if our listener is null, which means the game object was destroyed, we remove it from the list of listeners, and else we raise this event. So this may seem like not much of a feature right now, but in the next video we'll go over how these two elements can be used to make a runtime debug window to track various variables at runtime. So this sums it up for today. As you can see, there are many ways to extend upon the scriptable objects as presented by Unity, and I hope that this was a great help to you. If you liked the video, leave a like. If you want to stay tuned for the next videos in the series, be sure to subscribe. And since I'm pretty new at this, if you have any feedback, it is all welcome. Write down in the comments section. Your opinion is well valued. So once again, this was Max from Exalted Code, and until next time, happy coding.